Hello everyone. In this video, I'm going to show you the three different methods of calculating equity beta and show you why there is just only one method of calculating beta and the three different methods are just in fact variation of the same base formula. The first method normally shown to calculate beta is called the covariance variance formula, and beta is equal to the covariance of the market return with respect to the equity return divided by the variance of the market return. Let me show you the calculation of beta of Google stock using S&P 500 as the market portfolio. I used Google Sheet to download the data and used monthly data for 5 years for this purpose. You can click on the link above to see my video on how to convert daily stock data from Google Sheet to monthly data. You have to be aware that there is sample covariance variance and population covariance and variance. But I'll show you that using either sample or population variance, both will lead to the same answer. The reason for this will be clear by the end of this video. To get the sample covariance, we use the covariance.s formula, and sample variance is given by the variance.s formula. For population covariance and variance, you put .p instead of .s. As you can see, both sample and population formula resulted in the same beta, which using this data set for Google is 0.9928. The next formula used to calculate equity beta is the correlation standard deviation method, which is given by the Pearson correlation of the market return with respect to the stock return multiplied by the standard deviation of the stock return divided by the standard deviation of the market return. Using this formula to calculate beta, we have to understand there is no population or sample correlation. There is just correlation. But we do have population and sample standard deviation. We can calculate beta like before, and we see that using either population or sample standard deviation results in the same beta, which is again 0.9928. The last method is the slope or regression method. In this, we will use either spreadsheet's slope function, or if you are using Excel, then we can go to the data analysis ToolPak and use regression option to split the whole regression results. Slope function actually returns the linear regression line without having to get the entire regression output. Before I show you the slope or regression method, let me show you the scatter plot of Google with respect to S&P 500. That is, Google return is in the y-axis and S&P 500 return is in the x-axis. As you can see in the scatter plot, there is no exact linear relation between these two variables. When we do regression, we are trying to fit a line based on the ordinary least square method. This ordinary least square line minimizes the square of the residual by adjusting the slope and intercept of the line. You can see if I fit a linear regression line, that it gives the same beta of 0.9929, which is just rounded to 4 digits. You can use Excel's data analysis ToolPak to get the entire regression output, which will have the beta and intercept. You can also choose to output the scatter plot and regression line using this method. Or you can use the standalone slope function, which will just give the slope or beta of the linear regression line. Here known y's are the Google return and known x are the market portfolio return. As you can see, all of the method returns the same beta. Now let's try to understand the relation between these three methods. We'll start with the easiest relation, which is between the covariance variance and this correlation standard deviation method. Correlation is the normalized covariance between two variables, and this makes correlation unitless with a range between -1 and +1. -1 correlation is called perfect negative correlation, +1 correlation is called perfect positive correlation, and zero correlation means there is no correlation at all. the formula for correlation is given as the covariance between two variables divided by the product of the standard deviation of the two variables. Since standard deviation is the square root of the variance, I have chosen to represent the formula in terms of variance here. Now the covariance variance formula is given here, and if we multiply and divide the right hand side by the product of the standard deviation of the two variables and rearrange like shown here, we get the second formula of the correlation standard deviation. As we saw in the earlier slide, the covariance divided by the product of the standard deviation of both variables is the correlation. Market variance can be restated as the square root of market variance multiplied by itself, which gives us the correlation standard deviation formula. This brings us to the main method for calculating beta. Beta is generally defined and calculated in terms of simple regression of the stock return with respect to the market return. The equation of the line is of the form y, that is stock return, equals to the alpha, that is the intercept, plus slope, that is the beta, multiplied by the market return, plus the error term epsilon. We can estimate alpha and beta by minimizing the square of the residual, which is the epsilon, and taking partial derivatives with respect to alpha and beta and solving the system of linear equation. We can get the estimators for the alpha and beta. You can check the derivation of alpha and beta in other videos. Here I'm just showing you how the beta is calculated and what the final formula looks like. So once solved, the beta formula is shown here. The numerator is called the SSXY and denominator is called the SSXX. If you look closely, SSXY is the covariance of the stock and market return. SSXY is the variance of the market. All you have to do is divide XXXY by n for population covariance or n-1 for the sample covariance, and you do the same to SSX for the market variance. I hope you found the relation between the three methods interesting. Please do like, share and subscribe. Let me know of your thoughts in the comment section. Thank you for watching.